Hi, and welcome to this new video. In our previous video, we talked about recent advancement in AI image generation and how this can easily fool the human eye. In this video instead, we will see how the increased realism reached by fake-generated image make it necessary to implement every year new, robust and accurate fake image detectors. In principle, detectors of image generated by computer graphics methods leverage lighting, geometrical and other image inconsistencies using stochastic method. Nevertheless, most of this method got outdated and unreliable as soon as images start to be generated by artificial intelligence or AI-based method. In fact, the artificial intelligence method used to create fake images learn from large dataset how to replicate the camera acquisition process, generating hyper-realistic pictures of real-world content, which are undistinguishable to human eye and needs to implement other artificial intelligence to distinguish them from real images. Initially, artificial intelligence detectors based on the ResNet 50 were implemented and fine-tuned to be able to generalize to multiple generative methods based on generative adversarial network, such as StyleGAN 1, 2, and 3. Nevertheless, ResNet 50 method struggle on a new generative model based on stable diffusion, and where images are generated from prompts and not anymore from random noise. As a consequence, to cope with the previous mentioned problem, ResNet 50 based fake image detectors need to be retrained on large set of fake images generated possibly with the diffusion model. Plus, they also need to adopt a very strong and aggressive data augmentation to being able to generalize to the previous seen fake image generation, such as the generative adversarial one. More recently, AI fake image detectors start to exploit embeddings coming from large language models or LLMs, normally used for image captioning. Surprisingly, in the literature, it was demonstrated that embeddings coming from LLMs of real and fake images follow two distinct and separate distribution, which can then be exploited by fake image detectors, providing an incredible generalization and accuracy. On the other hand, it is still unclear how all this detector works on real-world case scenarios. Specifically, how do they work when a fake and a real images are shared and downloaded from a social network? In fact, social networks nowadays is the main platform where we upload and download our photos. However, to cope with the data storage limitation, social network also applies severe compressions and image processing that deteriorate the information that we normally use to detect if an image is real or fake. For this reason, we are not just interested in generating a new large and diverse dataset of fake images created by some of the most modern fake image generators, but also in sharing this image on many social networks in order to assess their impact on fake image detectors and implement one robust to such adversarial and real-world case scenario conditions. But we will introduce our dataset in our next episode. Thank you.